Hi everyone, welcome to this video, and in this video we're going to discuss about end behavior of graph polynomial functions. So when you say end behavior, there are two things that you consider, such as the leading coefficient and degree. So I have here a table that will be our guide in finding out the end behavior of a graph. Now, you look at now the leading coefficient and the degree. No, the leading coefficient, it could either be positive or negative. It cannot be equal to 0. So therefore, it could be positive or negative. Now, when you talk about the degree, it is the highest exponent in a given polynomial function. So it could be either even or odd. Now, when we say end behavior, that would be the continuity or continuous behavior, or it will be the value going up as it going down. Now, let's look at this one. If the leading coefficient is positive and the degree is even, there is two behavior that we could look at. The first one, on the right side of the graph, it would go up, while on the left side would go down, would go up as well. So if it is even, it would go up on the same manner. However, if it is negative, we could look at this. If this is going down, this is also going down. So that is now the behavior if it is an even polynomial function. The next would be odd. So if it is odd, there is an inverse relationship. As you can see, if it is an inverse relationship, if it is positive, it's going up, and then on the left side would lead us to going down. So technically, that's how it works. Now, next, let's go with the other one. So if this is going up to the left side, and the other one would be going down. So what would be our basis? The basis could be, at first, if it is like the basic graph, the basis would be the origin. However, it would depend upon the graph. So we will have a basis as the basic graph. So let's go as the origin as the center. Now, I have here an example. Let's have here this example. Y is equal to 3x. Now, if y is equal to 3x, let's identify the following. Let's identify the leading coefficient. The leading coefficient is 3. And the degree is 1 because it's a linear. So, technically, it would have an intersection at 0. So, I think this, when you sketch the graph, it looks like this one. Now, when you look at this one, as in this is the origin. Now, this is now the right side. Is it going up? And this is now going down. When you look at now our basis, it is odd. And then, the leading coefficient is positive, which is 3. So, therefore, this is the thing that we see on our behavior. The end behavior, this is going up, and then on the right side, and then going down on the left side. Okay, let's have another example for you to explore. Now, I have here this one. So, I think you could look at this. So, once again, it's a linear function. Y is equal to negative 4x. Now, identifying now the linear equation. The leading coefficient, it's negative 4. And then the degree is 1. Now, let's have now, the leading coefficient is negative 4. So, we're going to negative. And then odd. So, this is the thing that we want to see on the behavior. Now, as you can see, that is, it would intersect now the origin. So, this is now going up on the left side and then going down on the value of the y on the right side. So, as you can see, this is the thing that we look at it. Okay, now let's have another one. So, this is now a quadratic. So, let's look at now the leading coefficient. The leading coefficient is 4. And the degree is 2. Now, analyzing now our table, leading coefficient is positive, and then the degree is even. So, therefore, we're looking at this one. As you can see, if that is now a quadratic, the behavior of the graph looks like this one. On the right side, it is going up, and then on the left side, it is going up as well. As you can see, if you know how to look at the vertex, you would see now the behavior or the leading coefficient when you were in grade 9. Okay, now let's have another example. Another example is this one. So, the leading coefficient is negative 2, and then the degree is 2. As you can see, this is the thing that we're looking at. So, negative, and then even. Now, so you can see that's now negative, so the behavior of the graph looks like the end behavior would be like this, going down, then going down as well. That's how it works. Now, let's go on this one. If I have now a cubic function, so the leading coefficient is 5, and then the degree is 3. So you can see on a positive, and it's odd. So this is now the thing that we're looking at it. So it's like an S. So this is now how we look now, the graph. So this is now the thing that we say it's going up to the right and then going down to the left of the graph, because we're looking at it on the basic. So that's now on a cubic. Now let's go another one. So y is equal to negative 7x cubed. Now as you can see, this is now negative 7, and then this is 3. So as you can see, that's negative. I think this is the thing that we're looking at. So this is now the behavior of the graph. So the end manner is going here and then here. So therefore, it's going up to the left and then going down to the right. I hope you learned something on the end behavior of the graph of a polynomial function. You may explore that when you know now when they're shifting to the right, and then going up, the graph would go up and down, or it would be bigger. So there will be a lot of complexity. So on the next video, I think I would try to give you some examples of that. Thank you for watching. Have a great day.